Welcome dear students to another video on integration by parts. So this is your third part on integration by parts, and in this video you're going to learn about three standard integrals, and those are mentioned as 1, 2 and 3. Okay, so after learning these three standard integrals, you will learn, or rather you will solve, two kinds of integral. So one is A, that is the integral of this form, and B, the integral of this form. Okay, and how to solve these kind of integrals, rules are given here, so you may pause the video and note down all the formula. Now this is my first question on today's topic. So question says that evaluate this integral. Now if you compare this with type A and type B, this will fall definitely under type A, isn't it? Now type A says that we have to express whatever is within square root sign as the sum or difference of two perfect squares, isn't it? So if I call this as I, then this can be written as 25x square plus 16 can be written as, so first 25 has to be kept common, so in that case this becomes x square plus 16 by 25, isn't it? Now this is 25. Okay, now this can be written as x square, this is already a perfect square. Now this can be written as 4 by 5 whole square, isn't it? Now basically we have expressed this as sum of two perfect square because there is a plus sign out here, isn't it? So therefore your integral I will change into, see here carefully, integral square root of this entire thing can be written as this much, isn't it? That is 25. We have x square plus 4 by 5 whole square, isn't it? So we have dx also. Square root of 25 is 5, which can be kept outside integral sign. So we have integral x square plus 4 by 5 whole square dx. dx. Now this one falls under your, see there are three standard integrals given to you, isn't it? So this falls under your first standard integral. So the formula for that, if you refer, is, okay, so 5 is outside, so let me put a bracket here. So formula says x by a, so x by a is how much? A is 4 by 5. Yes, so we have square root of, see here carefully, square root of x square plus a square, that is 4 by 5 square. Yes, plus a square by 2, so a square means 4 by 5 whole square, a square by 2, 2 is 2 itself, right? And we have log of x, so x is x itself, plus square root of x square plus a square, x square plus a square is 4 by 5 whole square. Okay, so you can close the logarithm, this model sign, and you can close the bracket also. Now you can put a constant of integration. Okay, now this can be simplified further, so this can be written as 5. Okay, so this is your, so this 5 goes to the numerator here, so becomes 5x by 4 square root of x square plus 16 by 25 plus, this is your 16, okay, and this is 25 square, and again 2 is also there, so becomes 50. Okay, so this is log x plus square root of x square plus 16 by 25. Okay, with constant of integration. So this will be your answer for this particular question. So you may pause the video and note it down. Okay, so this time I've got this integral, let me call this to be I. So again this falls under your type A. So type A says that this quantity, that is 3 minus 2x minus x square, has to be expressed as sum or difference of two perfect square. Now remember, you always need to keep the coefficient of x square to be 1. Here what is the coefficient? It is minus, so this minus has to be kept common, so becomes x square plus 2x minus 3. Okay, now we have to express this as sum or difference of two perfect squares. Let's see how to do this. Now as you people are quite familiar with this kind of work, because we have seen this kind of work in earlier few sessions also, isn't it? So in this case, this becomes minus, this is your a square plus 2 a is x plus into, we have to put b in such a way so that you'll get 2x. Obviously that number will be 1, isn't it? So if this is your b, then b square is 1 square, but this is your extra. So in order to balance this, I'll put 1 square minus 1 square, and we have got minus 3 also, isn't it? So this is minus, so can I write this as x minus, x plus 1 whole square? Can I do that? Yes. So this is 1 square, which is 1, so this is 3. So altogether this is 4, which can be written as, okay, let me write it as 4 only. So this can be written as, after multiplication with minus, 2 square minus x plus 1 whole square. So therefore your integral I will become, see here carefully, so this becomes square root of this entire thing is this much. So 2 square minus x plus 1 whole square dx. Okay, after that you can directly put the formula. So formula is, you have to go for 3 standard integrals, and this falls under your category 3. Okay, so this is your third standard integral, which says this will be equals to x by 2. So this entire thing is my x, remember. Okay, so this is x by 2, so becomes x plus 1 by 2. Okay, square root of a square minus x square. So a square minus x square means the same thing. So 2 square minus x plus 1 whole square. Okay, plus a square by 2. So again a is 2, so that's why 2 square by 2. Now this time sine inverse x by a. X is x plus 1, x plus 1 by 2. By a, that is a is 2 here. So we'll put a constant of integration out here. So this and this gets cancelled. So this is x plus 1 by 2. You know what? 2 square minus x plus 1 whole square is equals to this much. So this can be directly written as 3 minus 2x minus x square, this thing. Okay, because this is equal to this much, isn't it? Plus this is 2 sine inverse x plus 1 by 2. You can put a bracket out here with a constant of integration. So pause the video and note it down. Now let's observe this one. So again, let me call this to be integral I. Okay, so this falls under which category? This falls again under type A kind of problem. Okay, so we have to express x square plus 2ax in the form of sum or difference of two perfect square. It's very simple, you just see it. So this is x square, that is a square plus 2a. Now you need to choose a b such that you'll get 2ax. Obviously that number will be a. So this a is your b, so we have b square. But this is extra, so in order to balance this, I'll put this also. Okay, now see here carefully. So what is this? This is x plus a whole square minus, you have got a square, isn't it? So that's why your integral I can be written as integration of, okay, so this thing can be written as x plus a whole square minus a square dx. Now this falls under which category? This falls under your standard integral second one, isn't it? Which says x by a. So formula says x by a. So x is x plus a by a square root of x square minus a square. That is the very same thing. So x plus a whole square minus a square minus a square by 2. Okay, so a square by 2 log x, and that is x is x plus a, remember, x plus a plus square root of x square minus a square, the very same thing, that is x plus a whole square minus a square, remember this. Okay, so we'll close this. Okay, now actually you have to put a constant of integration here, so you can put that also, so plus c. Okay, so this is x plus a by a, you know this, right? So this is equals to this much, so we can directly, instead of this, we can write x square plus 2ax minus a square by 2 log So we have got x plus a, and again this is what? This is this much, which is square root of x square plus 2ax, and we'll put a constant of integration. So this will be your answer for this particular question. Now let's observe question number 4. Now this do not fall under any of type A or type B. Let's do rationalization out here. Okay, so for that we need to multiply this by this one, isn't it? Yes, so we have x minus square root of x square minus 1. Okay, now in that case this integral I will change into, so we have x minus square root of x square minus 1. I'm just doing half for this. Okay, so this is a plus b into a minus b, so this becomes a square minus b square, that is b is square root of x square minus 1 whole square dx. Okay, so let's simplify this. So this is x minus root over x square minus 1 in the numerator. In the denominator we get x square minus this, and this gets cancelled, so we have got minus sign outside, so it becomes x square plus 1 dx. Okay, so this 2 gets cancelled, so this is actually equal to square root of this by 1, means x minus square root of x square minus 1 dx, isn't it? So this can be written as integral x dx minus integral x square minus 1 dx, isn't it? And this 1 can be written as 1 square. Now this falls under your, again, out of those 3 standard integrals, this falls under second category, and this is very simple. This is just x squared by 2. Put the formula for this out here and put a constant of integration. That will give you answer for this particular question. Now let's take this problem. Clearly you see that this falls under your type B, isn't it? So this is your type B problem, and here the rule says that this, that is px plus q. Okay, so px plus q has to be expressed as a into derivative, that is d by dx of whatever is there within square root, that is x square plus x plus 1 plus b. So this is the rule. Now after that what you need to do is you need to find the value of, okay, just wait a minute, this is not plus, I guess this is minus. Okay, so this is minus and this is also minus. Now after this what you need to do is you need to find the value of a and b. So let's do that. So this can be written as x minus 1. So a into, now the derivative of this will be, for x square it will be 2x, for x will be, it will be 1. Now for constant it will be 0, so we need not write that. Now let's separate x term and the constant term. So you get 2ax plus b minus a, isn't it? Please check. So in that case we get, so comparing, so if I compare both sides, the coefficient of x here is 2a and the coefficient of x here is 1. So 2a will be equals to 1, which gives me a equals to half, isn't it? And b minus a, that is the constant term, okay, will be equals to minus 1, isn't it? Now you know the value of a, which is half. So from here the value of b turns out to be half minus 1, which is minus half. Okay, so therefore your integral I will become, okay, so this is your, okay, so this x minus 1 can be written as this, isn't it? See here, so you can call this as star because this will be useful here. So instead of your x minus 1 I'm going to write a into 2x minus 1 plus b. So we have got within square root x square minus x plus 1 dx. Okay, now let's open up the bracket. Okay, so after opening the bracket, this a is a constant, can be kept outside, so this becomes a 2x minus 1 square root of x square minus x plus 1 dx, plus similarly this b will be kept outside and this can be written as x square minus x plus 1 dx. Please check it, isn't it? Okay, now in this case, this first integral is integration using substitution. How? Let's see. So let me write. Okay, so this one, that is x square minus x plus 1 equals to t. So from here, after differentiation, you will get 2x minus 1 dx will be equals to dt. Yes? Okay, now this is all about your first integral. We will express this. For this falls under your type A, remember. And when type A says that x square minus x plus 1 has to be expressed as sum or difference of two perfect square. So this can be done in this way, isn't it? Please check. Yes, so I have to put b as 1 by 2 because I have to get x only. Yes, so this is your extra, so we'll minus or subtract this, and we have plus 1 also, isn't it? Okay, so this can be written as x minus half whole square. Okay, so this is 1 by 4 plus 1, which is plus 3 by 4, isn't it? So 3 by 4 can be written as root 3 by 2 whole square. Okay, so therefore your integral I will change into a. Okay, so what is the value of a? A is half, so this becomes half integral. Okay, so you know that this into dx is dt, and what is this? Square root of t, and we have got dt plus b. And what is b? B is minus half, so that's why it becomes minus half integral. So we have square root of, so this can be written as this much, so that's why I've written x minus half whole square plus root 3 by 2 whole square dx. Okay, first part is easy, so this is half square root of t. The integral of this will be t to the power minus half plus 1 minus half plus 1. Minus half is there. Okay, so this again falls under the first of the three standard integrals, which says this will be x by 2, that is x minus half by 2 square root of x square plus a square, that is this entire thing. Now what is this actually? If I write this, that's also fine, but instead of this, if you write this, that will be better. Anyway, at last you have to write this again, isn't it? Okay, plus a square by 2, that is a is root 3 by 2 square by 2 into, we have got a long one, that is log x. X is x minus half plus square root of this. Yes, square root of this means actually this is x square minus x plus 1. Okay, so you will close this and will put a constant of integration. So after this, okay, I don't have space here. You can do one thing. See, this is going to be half. 1 minus half is half. So half and half gets cancelled. So this is just, I'm sorry, there's a mistake out here. So this is t to the power half, isn't it? So this is not minus half. So this is 3 by 2. Okay, so 2 and 2 can be cancelled. So you will get 1 by 3 t to the power 3 by 2. Okay, that is t is t is this one. So x square minus x plus 1 to the power 3 by 2, and rest you will just simplify it and write. So minus half, this whole stuff is there, so you'll write whole stuff within this, and that will be your answer for this particular question. Okay, so dear students, let's see this question now. So here in this question, this particular integral falls under which category? This falls under your category B, isn't it? So this is your px plus q, remember, and this is your quadratic expression. Again, the rule is same. We need to take px plus q equals to a into derivative, that is d by dx of x square plus a square plus b. Okay, so as usual, let me write this as a into, so this will be this 2x, isn't it, plus b. That is, this can be written as x minus b equals to 2ax plus b. Okay, so comparing both sides. So you see that 2a is equal to 1, right? So 2a is equals to 1, which gives me a equals to 1 by 2. And this b will be equals to minus b, isn't it? And b will be equals to minus b. Okay, so therefore your integral I, see this step is very important, okay? So this step is very important, so that's why, I'm sorry, this one, not this, the second step. So integral I can be written as integral, so instead of this I have to use this, okay? So it becomes a into 2x plus b, okay, using star, into square root of x square plus a square dx. Okay, so again a is a constant, can be kept outside, so this becomes 2x square root of x square plus a square dx, plus this b is a constant, so can be written as this much. Okay, I'll just show you this part. This is a direct formula, you will do by yourself. So here you need to again do the substitution. So let x square plus a square is equals to t. So from here you see that 2x dx will be equals to dt. Okay, so that's why your integral I will turn into a. So what is a is half. So half integral. So 2x dx is dt, isn't it? So what is this? Square root of x square plus square a square is t. So this is square root over t dt, isn't it? So instead of these two I have written dt, plus, okay, b is actually minus b, so that's why minus b, we have got square root of x square plus a square dx. Now your work is easy. Do this, and after that substitute the value of t to be this much and put a constant of integration. That will give you your answer for this particular question.